Hello, welcome to this webinar hosted by Lumo Radio and with our special guest today, Mr. Lars Wennerlund from Capture Visualization. Welcome.
Thank you. Thanks so much for having me.
All you out there, please go ahead, ask your questions in the chat, and that will make our life easier here as well. Then we know what to talk about. Lars. As I said, welcome here.
Thank you.
So you at the Capture, you're doing visualizers,
Yes,
for the viewers out there that might not have used any visualizers. What is a visualizer?
What is a visualizer? A visualizer is, broadly speaking, a computer software that visualizes a lighting design environment. It can be a theater or a building or a water fountain for that matter. So it's like a virtual reality for lighting.
Okay, yeah. And the benefit with that would be?
Well, you can use it as a tool to create your designs, but also to present your designs to someone else. You can create documentation material. And of course you can connect it with control equipment and use it also as a verification that everything is set up in a virtual environment before you run the show in reality.
Cool. So then connecting to today's topic with the data protocols.
Yes.
I guess you're dealing quite a bit with data protocols.
Yes. It's very central for us since we do want to connect with various controllers and equipment to get the DMX into our product for the visualization. Yes.
Yeah. So to get started on today's topics of data protocol, why not start out with the most common protocol in our industry, DMX protocol. DMX, yes. So it's been around for quite some time, since like '86.
Was that when it was standardized or when it?
No. So it was standardized in '98, but it was released in '86 by USITT. DMX. As probably everyone out there knows, it's a protocol, just basically up to 512 dimmer channels. And Lars, why dimmer channels?
Well, because in the beginning, basically there were only dimmers. You were interested in dimming lights, and that was all you could do with it.
Yeah.
And I think even before DMX, we used analog signals, so it was a 0 to 10 volt.
Yeah.
One electrical cable per dimmer.
And no one would ever need more than 512.
Never, ever. That was just too much.
Okay, yeah. So then the DMX channels, or the dimmer channel in this case. So in today's reality, so to say, where we have fixtures that have like what we call intelligent fixtures.
Moving lights, intelligent fixtures,
Yeah.
I mean, they're usually at around 30 channels at least today.
At least sometimes, yeah. And so how do you get that into your software?
Yeah, so I mean, we get the DMX in, which, as we said, is just like dimmer channels, and then we need the data to understand what they are supposed to do in moving lights, or even if it's just an RGB fixture, like the tube we have on the floor here, where you have one channel for red, green, and blue. We need something like a product library that knows how to map that data to what one device does.
Yeah. So you could say that each of and every one of those dimmer channels, they're actually a set of data that's being translated into what that particular fixture is supposed to do.
Yeah, so it's like a block of functions, basically.
So then to get it into your software, you use some sort of equipment to get it over to the network, or do you directly into the software?
First time we got DMX into Capture, it actually came over an RS-232 serial cable. So it wasn't actually DMX, but it was the same kind of data.
Yeah.
And following that was an artistic license. They had a red little, I think it was a serial cable thing with 1 or 2 DMX cables on the other end.
Yeah.
So you could get it into the computer because that was exotic.
Yeah. So you spoke about that, like not actual DMX in that. So DMX, it's on the electrical level, it's called RS-485, the bus type, and it's being used, and we're running it on quite special cables. Like, well, the cables, they should be 120 ohm impedance and so on. So, which means, by the way, do not use it on microphone cable. And as everyone out there probably knows, 5-pin XLR is the only XLR type that is part of the DMX standard. Although you are also allowed to actually use it on RJ485 cable, but on the XLR ones, 5-pin is the way to go. These dimmer channels, they're continuously repeated.
Yeah.
Over and over again.
I was speaking with a colleague today. He was wondering what happens if you lose connection with the DMX signal, if you have issues getting back up again when you reconnect.
Yeah.
So I pointed out that it's designed for the fact that you might unplug and replug, and continuously it's the full image of information constantly being fed to you.
Yes, it's kind of like a TV broadcast. You don't have to rewatch the entire episode if you started after the first commercial.
Well, now we have digital TV, so now you actually do have to do that. But when we had analog TV back in the day, this was the case indeed.
Yeah, so this is getting repeated over and over again, and up to like 44 hertz when using a full DMX universe.
Yeah.
And a universe, for that sake, it's what's on the cable, basically, on the DMX cable. So it contains up to 512 dimmer channels of data. And the 44 hertz, when we get to video and so on, like, nothing is 44 hertz.
No, I guess the number just comes from what was simply possible when they decided stuff back in 98.
Yeah.
But today the number 44 makes no sense. I mean, there's no video that runs in 44 hertz. So if you want to sync your lighting design to video, you might run into trouble. It's the classic issue when you have 25 FPS video and you want to play it on a 30 FPS LED screen. That does not look good at all.
Yeah. So, but when running video or running that type of lighting, when you want to synchronize it to video, wouldn't it then be better to use like Ethernet-based protocols, like streaming ACN or ArtNet?
Well, you do get more flexibility in terms of the refresh rate, because with an Ethernet protocol you could change stuff, whereas the DMX cable stays.
Yeah.
But is that actually true? Is the DMX cable locked to 44 hertz?
No, it's not. It just happens to be like the fastest you could do on with the 512 channels.
So if you go lower...
Yeah, you could go lower. So you could go, for instance, to 30 hertz if you want to run it with a 30 hertz video, or 24 hertz or so. But that also requires your console or your infrastructure equipment to actually be able to be configured when it comes to the as they call it, the refresh rate and so on of the data. And speaking of that, with streaming ACN, so while DMX is on the RS-485 cable, obviously it becomes a lot of cables doing the larger shows. Like Eurovision.
Since one universe isn't enough.
Yeah, since one universe isn't enough for anyone, obviously, even though no one would ever need more than 512 dimmer channels. But so, do you have a feeling for, like, let's say a show like Eurovision Song Contest or anything like that? How many universes would that be?
I mean, these days it's just a race to increase the number.
Yeah.
But we're easily talking above 32.
Yeah.
And then the sky's the limit, especially if you have LED content over DMX.
Yeah.
I guess you could even divide it into how many universes you would use for the moving lights. Maybe 20 to 60, something like that.
Yeah.
And then you might have another bunch of 50, 100 universes which just has RGB values for some
For the
LED
video.
tubes or LED
Yeah.
pixels and stuff like this. Yeah.
So, with the introduction of streaming ACN, which is basically you take a universe of DMX data, you package it into an Ethernet frame in a standardized way, throw it over an Ethernet network, and then all of a sudden you have bandwidth to do like loads,
Gazillions of universes. Yeah. The only issue is you want to send them. I mean, you have, let's say you have 50 universes, you have lots of bandwidth, but that of course is assuming that you can spread it out over time. So by the time you've sent the last universe, it's time to send the first one again.
Yeah.
So you get like a rolling
Yeah.
update. So it's not like you get all the 50 universes simultaneously. Necessary.
Yeah, and if doing that, that puts a lot of stress onto the network infrastructure as well. So both ArtNet and Streaming ACN being the two most commonly used Ethernet-based protocols for this. It's not the only one, but it's the most used ones at least. With the introduction or the latest revision of Streaming ACN, it's actually introduced the concept of synchronizing.
Yes. And I haven't read in very much detail, but I presume the idea is that everyone buffers the DMX they received, so that all of the receivers are ready, and then there is one signal that says, all right, let's do this.
Yeah, go.
Yeah.
So basically then allowing, like, you don't need to have the console outputting like 60 universes instantaneously, overloading all the network infrastructure, but instead you can like put them out one by one in a more controlled fashion, and then it's just a short network package going to everyone. It's like, go.
It's kind of like back in the days when you had analog lighting consoles and you had 12 dimmer channels you wanted to set to level, and then you did a scene change.
Yeah.
You didn't want to do the 12 live. You wanted to do that and then go the next preset. Yeah.
I'm just checking here sometimes if we have
any
comments,
questions?
Any questions or so. So if there is any questions along the way, just write them in the chat and we'll try to catch them at least. Streaming ACN, ArtNet. ArtNet is not a standard, is it? But Streaming ACN is. So what's the difference?
Very philosophical question.
Yeah.
In my mind, there's two ways of viewing the word standard. One is once it's common enough, it's a standard. And the other one is whether it's been created in a standardized process by a group that follows a certain structure and or form of organized work.
Yeah.
Basically. So, but yeah, as you say, ArtNet comes from artistic license.
Yeah.
And was originally something they had. It was the language of their devices.
Yeah.
And
basically allowed their network devices to communicate and output DMX where the DMX was needed.
Typically, I think DMX to Ethernet converters.
Yeah, I think that was where it came from. And I say, like, obviously the benefit of that being is a much faster process, getting something onto the market that basically, solves people's problems here and now, while making a standard like Streaming ACN or other standards. DMX is one of them, RDM and so on. Yes, but it takes a lot of time. It could take many years, and obviously that is parts of it being the process that you need to go through, and also that is a lot of people involved. So when making a standard, in this industry, ESTA is the organization in the US that is there, an ANSI accredited organization allowing them to publish ANSI standards, which both DMX, RDM, and Streaming ACN, ACN, etc. They're all ANSI standards.
Yeah.
But that also means that it has this process that you have to go through. Forming a task group that gets the assignment of solving these problems, writing draft of the documentation or the document, publishing it for public review.
Yeah.
So
it's like a democratic process.
Yeah, it's like pissing everybody equally off.
Yeah.
More or less. But so obviously it takes a lot longer time. Is it for any benefit?
Well, obviously the product, the specification itself, the document that describes what's been decided will have a few issues. It will be well thought, and ideally it will solve a fair amount of people's problem. It's that part about pissing everyone off equally. So I mean, you can't work everything into a standard. So at some point, probably you will have to leave some parts out.
Yeah.
But I imagine in the end you will have something balanced.
Yeah.
That works well.
And after all, you could revise it later on if needed.
Indeed.
That takes another couple of years.
Which presents another sort of challenge, of course, in that once you have a standard, you might think that you're done, but then you're ready for the next version of the standard. As with most IT equipment and software.
Yeah.
Once you've done a release, it's time to work on the next one. So.
Yeah. Streaming ACN, was it like 64,000 universes that the protocol supports?
Something like that.
Yeah.
Yeah.
ArtNet's like half of it, so
yeah.
Are they both also more than anyone would ever need?
I think at this point, yes. I would say that the practical challenge of setting up your equipment on site, it's reached the point where, I mean, it would take so much time to set up more equipment that you just don't want to do that kind of show.
Yeah, I think, yeah. So, when talking about ArtNet and Streaming ACN and so on, so they're both protocol which basically just take the same 512 dimmer channels as we spoke about earlier, put it into a well-defined packet and send it off over the Ethernet.
And off it goes.
Off it goes, yes. So, but what's the difference?
What's the difference? Well, they are very technical, the differences, and it's all based on different technology within Ethernet working.
Yeah.
Can you say Ethernet working?
Yeah, I guess so.
Yes, yeah. So ArtNet uses what's called broadcast but these days also unicast, which is a bit like a radio transmission. It's like an FM wave that goes out and everyone can listen in. Whereas Streaming ACN is more like a subscription service. If you haven't paid your subscription, you won't receive it. And ideally your subscription doesn't get lost.
Yeah.
And your payment doesn't get lost. So you actually receive what you want.
Yeah. So the point being more or less that with the Streaming ACN, the equipment, the fixtures or the Ethernet to DMX gateways and so on, they all subscribe to the data they want, so that they don't have to deal with the data that they're not supposed to get.
The difference with the FM radio is that with the FM you tune into one channel, but in this case you kind of have to listen to all the channels at once.
Yeah.
Which is bad.
Yeah.
So you prevent overloading the devices by saying I want this universe only.
Yeah. And that puts it a bit into when it comes to the actual network infrastructure, because that is what's actually supposed to deal with this so that the devices does not have to deal with it.
Yeah. Yeah, because you basically receive it, whether it was broadcasted or multicasted.
Yeah.
But it's all in the network infrastructure to keep track of whether you should have everything or something.
Something, yeah. Getting on some on this. So, if you're doing large shows, you should look at switches that supports IGMP, because they're the switches there that are going to keep track of who's interested in what data and so on. Otherwise, you could get into the issue that like you're basically overloading like poor equipment with slow processors out there doing these conversions and so on, like throwing 100 universes on one poor device. Can you explain in very layman's terms what do IGMP actually do?
IGMP is that's the part that sort of keeps track of who should have what, and how to get it to the right people.
Yeah.
Because you are setting up a lot of network devices, and the data also has to find its way to the receiver. And you might unplug a cable from the switch and plug it into a different port, and then the network has to understand that things have to go another way. I've simplified quite a bit.
Yeah. Yeah, but and that could actually be an issue. So even though a generic recommendation could be to use switches that supports IGMP whenever you're doing large shows with, let's say, more than 20 universes or so. But you also do have cases where this could potentially be an issue. In, for instance, the film and TV world, it's not uncommon, as you say, to unplug and plug stuff in all the time. And the way IGMP is supposed to work in these switches is not really well defined. So it could sometimes be a little bit glitchy when you move something from one port to something else. It does not necessarily get the data all the time. So even though it's a rule of thumb, there are exceptions to that rule of thumb as well.
Yeah. I'm speculating a bit, but I guess this was invented for things on a larger scale, like we lost that Atlantic link. So if it takes 2 minutes before we find the one over Spain and Brazil, that's kind of fine.
No, but it works quite well, in relatively static environment. Like if you're building an office building or something, a typical office network. The network stays more or less the same throughout the day. So the technology is developed for like our regular emailing type of applications, even though it's used on scale in like IPTV and so on, where your set-top boxes subscribes to the channel you're viewing right at the moment. But that's also the case, like your set-top box tends to stay sort of where it is.
Once you've set up your TV studio, you don't really go around
plugging things.
No.
So when moving from the DMX world, or say the cable DMX world, that's sort of you have the quite basic. Let's see if we can bring up here. So
right.
So here is actually a. Let me see if I could. So they will see this as well. Here we have a DMX, an Ethernet DMX node. We tend to have like a number of ports, and obviously you get one universe per port.
Yes.
It's quite easy to understand.
One universe per cable. Yes, it's very.
It's kind of obvious.
There's nothing hidden going on about it at all.
Yeah, exactly. So you plug in, if you have, think of something like this, but the other way around, like these are output ports, but if we consider something that has import ports, it would be quite obvious, like either cable is plugged in and has data, and if it does, it's from one source.
Yeah.
But in the Ethernet world, that doesn't really needs to be the case.
It can be really difficult in Ethernet to see what's happening on the network.
Yeah.
To understand how many universes are floating around, where they are getting. I mean, if this was something like a merger, then if you had the cable here, you would know you had the signal here.
Yeah.
But if you bring a network cable to a device, you don't know if the universes are actually coming there or not.
No, so you kind of, and you can also have like several sources of the same universe.
Yeah.
But with different data. So
yeah,
this can be really confusing.
Yeah, especially so if you design something like a backup environment where you have a console running and a backup console running, and the idea might be that if the primary console fails, you want the backup to take over. So what happens is you feed the DMX over Ethernet constantly from both sources, and then on the receiving end, if you lose one of them, you use the other. So basically you have the same data coming, but from two different directions, and you have to constantly choose which one to use.
Yeah. So, and the concept of doing that, we call merging.
Yeah.
And there's a number of different ways you can do the merge. First of all, we have what you spoke about. Basically, you have one primary and one backup.
Yeah.
One having a higher priority than the other one.
Yes.
Exactly. So that priority type of merge, it's supported by streaming ACM.
Yes.
Is it supported by ArtNet? I don't
think so.
No. But then you also have the case where you have the same priority on data.
Yes.
What do you do then?
Well, there are cases where you want to use the highest DMX level, the HTTP merge. And then there are cases where you even want to cherry pick channels from different sources. There are solutions where you have, say you're controlling pan and tilt-off fixtures with one system, but the color channels of the fixtures with another system. So you have like interlaced data coming in that you need to merge on a per channel basis.
Yeah.
So, I mean, in theory, you could have any system up to rolling a dice and choosing on the go which one to use. But I think with streaming ACM, there is a formal requirement that in the product documentation you describe what the merging strategy is.
Yes. So and this might be one of the things where it could differ, like one of the benefits actually with having a standard, a formal standard, where you can actually put that type of requirements into the standard, that if your product is supposed to be allowed to be marketed as compliant with the standard, as a manufacturer you're also required to put into the documentation how you're handling this type of situation, so it's easy for the user to actually figure out what's going on.
And as we sit here, I realize we haven't done this. There is a standard. I mean, what is definitely built in is the idea that there is a priority per universe.
Yeah.
So as long as a higher priority is coming in, you should use that. And when it's gone, then after a certain amount of time, which is not well defined, you might switch to something of a lower priority.
Yeah. And let's say if we have HTTP merge, which is then highest stakes precedence. So for each and every channel in the DMX universe, the piece of equipment will go through the data from the number of different sources. And this is also the case with different types of devices could support different amounts of sources. So this could be quite confusing as well. Like you can have one piece of equipment dealing with the situation you have perfectly fine. Maybe it supports 8 sources, can track 8 sources. And then you have another piece of equipment that can track 4 sources.
Yeah.
And then all of a sudden you might not get the data, or you get like it
switching back and forth
and so on. But in the type of device we had over here that we looked at, the Ethernet node, my experience is that HTTP is the most common type of merging done in these, since they basically don't know anything about the data.
Yeah, and if suddenly there is no data over a cable, then it's as if all the levels were zero.
Yeah.
Although at that point, I think that's the equivalent of actually pulling the cable.
Pulling the cable, yeah.
Or losing power in the sending system.
And it's, from an implementation perspective, it's a quite easy merge to implement compared to the LTP, like the latest takes precedence, because then you kind of you kind of get into a situation where what's the latest if you have two sources with different refresh rates and
if you've had a power loss and come back online and basically lost all reference in time, that's also an issue. But what I think the benefits of the old cable approach was that you would have a number of input ports in your merger. They were 4, so you knew it would merge up to 4. But I think there are definitely streaming ACM compliant products out there where they have not even thought about the problem that you might have multiple senders of the same universe.
Yeah.
Because, well, these specifications, they tend to be rather long. And if you're in a hurry getting your product out, you might read just the bits you need to get it working and not take the time to read through everything and understand all the situations you need to deal with that are not obvious.
Yeah.
Like the multi-sender merge problem.
Yeah. And how do you distinguish between two sources on the Ethernet?
Well, that can be difficult. But generally speaking, you have the IP address or sometimes MAC address that the message came from. And in streaming ACN, there is an ID field that each sender is supposed to give a unique value.
A globally unique, yes.
A globally unique value, such that you can keep them apart. But then there are other issues around that, like when you are moving equipment and you specifically want another piece of equipment to behave as if it was that other thing. So say you have a rolling tour with A and B equipment, then there are cases where you might want things to look identical so that you don't have to reconfigure stuff. There are a lot of pitfalls in Ethernet-based DMX distribution for sure.
Yeah, and it's you get to the point where you're going from basically just like dragging cables and plugging them in the right place to the point where you actually have to understand a lot of the inner workings of your infrastructure equipment.
Yeah. So the ID example I just mentioned, I should clarify that is actually more related to RDM, where every RDM device has an ID.
Yeah.
So if you've patched your lighting consoles to let's talk about RDM. If you patch your lighting consoles to control a set of RDM devices, and tomorrow you're with your show on another arena with the same rig but different devices because you're alternating the equipment, then you want to keep the same patch, although suddenly none of the IDs match anymore. And that is the challenge I was getting at.
And so you mentioned RDM. We haven't spoken about RDM so far yet. So RDM, you can kind of say it's an extension to DMX. Like, it's a completely separate standard, but it's written for basically live alongside DMX. While you have DMX for the control data, controlling the fixtures, RDM is used for feedback, configuration, and that sort of stuff. So it runs on the same cables, right? And
you can mix equipment, right? You can have...
Hopefully. If the equipment complies to the standard.
Right.
And this is a quite, I would say, if not common, so at least not uncommon situation where we have equipment that just assumes that everything on the cable is DMX. So in the standard, it specifies that there in the beginning of each, it's called frame, that is the 500 total channels that are repeated over and over again. In the beginning of the frame, you have something called a start code. And the start code specifies what type of frame this is.
It's the 513th channel.
Yeah, it's the 513th or the 0th.
It's fair enough.
And some fixtures, they just assume it will be DMX. So they never look at the start code. So when there is a RDM message coming along down the wire, it will just interpret that as DMX. So then you can get all sort of weird flickering going on in the rig. So if you have that, you can try switching RDM off. If it helps, then your fixtures is not DMX compliant. So then you can go back to your manufacturer of the equipment.
I think I may be mistaken here, but I know High-End had some equipment for a while. They called it something like the Universe Doubler or Expander, where you ran 2 DMX universes over one cable.
Yes.
I think they were using an alternate start code.
I think so, yes. So they ran basically then half refresh rate.
Half the refresh rate.
2 universes and an alternate start code. Specifying that this is not DMX, it's something high-end. Hoggish. Something high-end specific. And that is kind of... You can do that. Like there is a number of start codes that are registered. They're all available on the ESTA website. You can look them up. There are a number of them that are, so to say, registered belonging to different manufacturers. Yeah. One, for instance, is a special, coming back to this merge topic. One of them is registered to ETC. Where the package contains priority information, not only for the universe, but on a per channel.
All right.
So you could have different priorities from different sources on different channels, just to make things even more complicated.
So this is where the streaming ACN extension comes from.
Yeah,
that
for
ETC has for per channel priority then.
Yes.
Yeah,
so right. I don't think they actually never do it on the RS-485 wire, but I guess there's nothing stopping you from doing it. So with the RDM, there's been this really long, I shouldn't say rumor, but it's one of the misconceptions that often pops up, that people think that RDM is using the pin 4 and 5, which they aren't, because most people don't have DMX cables with 2 pairs.
We have a Swedish word for what happens with pin 4 and 5.
Yeah.
It's vaska.
Yeah.
It basically means put to complete waste.
Yes. So now you have this new word, WASC.
Yes.
So the RDM data is then, it's kind of, you can say it's interleaved in between the DMX frames. So you could say that it steals a little bit of the bandwidth. So depending on your type of show, you might want to switch it off when running the actual show. If you're doing like high speed, high synchronized strobes and that kind of things, could get a little problems on when there starts coming RDM packet in between. When you're plugging in this, like starting to run RDM on your, you've had your network with equipment, splitters and so on. So you need to make sure your splitters are bidirectional. Otherwise it could be interesting.
Yes, you have to make sure, as always, you have to make sure you have the right equipment.
Yeah.
And that can be hard.
That can be hard, especially since there's, with these standards, like the ESTA standards, DMX, RDM, streaming ACN and so on, There are well-specified standards, or at least specified standards. In some cases, maybe not so well-specified, but at least specified. But there is no formal compliance testing to these standards. It's kind of, you could say, they're self-certification sort of, where you, as the manufacturer declares themselves that they fulfill the requirements of the standard.
You test with the engineers. By the end of the day, they need equipment from other manufacturers to test with. And if you're a small manufacturer located in a remote, deserted island, then it will be very hard to get access to this equipment.
Yeah.
I think you have a nice little device here.
So we can have a look at that.
Flash it very quickly. It might be hard to see. This pretends to be, I think, 6 RDM devices.
Yes. So this is a little gadget from Howard Eaton Lighting in the UK. I would say anyone making an RDM controller should have at least one of these. There are 6 RDM devices into one box. And you can also configure them to misbehave in different ways.
Mischief mode.
Yes. So you can have different type of error modes that real-life devices shouldn't get into, but you'd be surprised to see how much going on these cables that shouldn't be able to happen. So any RDM controllers manufacturers, get one of these and put it into the error modes, and hopefully you'll get through everything of it. Yeah. At the end of the day, as a controller manufacturer, you kind of could expect to put some extra effort into actually being able to deal with these quirks and so on.
Yeah, but as with everything, things develop over time, so products that have been around longer may have grown more resilience towards various issues as they have been put in installations where they've discovered something weird.
Yeah.
There are some benefits with the Ethernet-based protocols, of course, in that often you can run them as computer software so that you do not need to ship physical equipment.
Yeah.
Although also in many cases the computer software is protected by licensing and dongles and so on.
So you still need...
So even then it can be tedious, but at least it is easier.
Yeah.
There are not that many manufacturers in the industry by the end of the day, so it's not enough just to test with stuff from your own country.
Yeah.
That just doesn't do it.
Yeah. Yeah, and it's... if you're implementing like streaming ACN or RDM or anything, you can look up the Plugfest. So in Europe, Plaza, the trade organization, organizing every year, at least when there's not any COVID going on. Yeah. But every year they arrange this Plugfest where manufacturers can bring equipment together and plug them in together, test and see how much that breaks, more or less. And in the US, ESTA doing the same things. Just come along, bring your equipment, plug it in, and see what happens. It's better that things fails in a controlled environment in a room full of engineers than out in the field with the end users.
It would have been amazing if there was like a permanent location, a lab, where each manufacturer had some equipment and you could always go there and test with the other equipment. But yeah, then someone would have to manage that, make sure everything is working and so on. It would be very expensive.
Yeah. And let me bring this up again, because when it comes to troubleshooting, DMX testers, it's kind of a must-have for any technician out there. So they come in all sorts of forms and functions as well.
And levels of pickiness.
Like I would say this one, for instance, is quite meets probably most people's demands. It's quite rugged and so on. But there are all other DMX test the manufacturers. You have, for instance, the DMXter from Goddard Design. It's compared to this one, I would say this one works very well for all the lighting technicians that are about to test and fault find their rig. While the DMXter is something that manufacturers of equipment should get, because it's really, really picky and it's really precise in its measurements. So while I would say that a lighting technician, he or she should be able to assume that the manufacturer have made sure that their piece of equipment, at least generating DMX in the right, does its job.
It's an interesting point that there are kind of levels of equipment that is for testing the network, equipment for testing the devices themselves, and then equipment that is used in the manufacturing to check whether it's even right from the start.
Yes.
And which one is this, since we mentioned
so this is from Swisson. We can bring it up like this. Swisson, there is a Swiss manufacturer. This is available in two different versions. One that is just supports DMX, and one that also supports RDM. So then you can actually use it as a RDM controller as well, changing DMX start addresses and so on from here, rather than having to get back to your console.
Right. So it's like a remote in a sense as well.
Yes, so kind of you unplug the cable from the Ethernet node, perhaps plug it in, and you can set something up before plugging the cable in and get back again. We haven't spoken really anything yet about like how to troubleshoot on the Ethernet.
Yes.
And so on. So first of all, you have this problem that, as you spoke about earlier, it's not really obvious what data gets where and so on.
Yeah.
And then I know when we spoke before this webinar a little bit, you mentioned that you've seen cases where people have testing tools that see data that some other, let's say, real application does not see.
Yeah, I mean, with Ethernet, it's one thing to get data going over the cable, but it's also another thing getting that data processed, especially if it's a computer, in the computer. Because the computer will be picky and say that it doesn't like data if it doesn't come the right way, and start filtering things. So with ArtNet, for instance, in the later revision with unicast support, the whole concept of unicast is that you send one piece of information and it reaches exactly one receiver. But one receiver here doesn't mean one device or one computer. So in the computer, it literally means one piece of software. So if you are running your ArtNet monitor at the same time that you're wondering why the ArtNet is not coming into your application, then you're creating a problem, because the unicast message can't reach two applications in the same computer. Unless one of them runs as an administrator and then can see things a normal application wouldn't see.
Yeah. Yes, you have like some of the testing, and that can sort of happen. My experience is that the same. You can get the same sort of scenario even when you haven't started two applications, because you can have one normal application that runs in user space as a regular user, where the data has to propagate through the operating system and the firewalls and potential antivirus softwares and so on before it reaches the application. While some applications that runs, in that case, also needs to run as administrator, because they're being run in what's called a promiscuous mode, basically allowing it to get whatever that gets into the network card on the computer.
A sort of example of that, I think, is Wireshark.
Yeah, so Wireshark
Test.
So now we might have the sound back. Had some technical issues here. So yeah. So getting back to Wireshark. So there was probably the single most used testing tool in the Ethernet world.
Yeah.
So can you explain a bit about what Wireshark does?
It lets you see what actually comes in the cable, all of the data from all of the protocols. You will see your email application, you will see YouTube streaming and everything. And you can filter that down to the specific protocol you're interested in, such as ArtNet or streaming ACN. So you can see the actual ArtNet as it's coming in, which is really handy. But again, you have to keep in mind that while Wireshark might see something, doesn't necessarily mean that another device on the network will see the same thing.
Yeah.
Or that even another application in the same computer will see the same thing.
Yeah. So it could actually be, sometimes from my experience when troubleshooting Ethernet, there are smart switches that can be configured in different ways. So me personally, I have a Netgear switch. One of their, I usually prefer like their, I would say, lower end prosumer.
Prosumer.
Yeah, the prosumer. It's the type of equipment. They're still cheap, but they will not break when you drop it into the floor.
Right. Rugged.
Yeah.
Right.
So but they have a series of switches that is called smart switches. So they offer a minimum number of configurations, and I have one of those configured to mirror all the data passing in and out of one of the ports onto one of the other ports. As with this IGMP thing that tells the switches how to set up and forward the data, your computer being plugged into one of the ports doesn't necessarily see the data going to this Ethernet node, because this one has joined, as it's called, joined the multicast group, sending out these IGMP packets, telling the switch to forward the data to this one, while your computer hasn't done that, so it will not see the data. Yeah. But in this case, I can plug, if I want to troubleshoot this device, I can plug that switch into, basically in line with this, and my computer will see all the data that pass in and out of the device.
Yeah. I would also like to mention the artistic license, what's it called, the DMX Workshop.
DMX Workshop, the application, yeah.
There's also something called the ArtNet Dominator.
Yes. We will, by the way, after this webinar is ended, we will post links to all the application and the equipment we're talking about here in the comments below the video when it gets posted afterwards.
Yeah. Yes. So with ArtNet, and now that there is Unicast in ArtNet, there is also a sort of subscription-like mechanism in there that lets the ArtNet controller ask what is on the network and then send information to the right channels. But when you run things like the DMX Workshop or the ArtNet Dominator, they will announce themselves on the network and can themselves cause data to go different ways. So it's very sensitive, and if you don't understand a lot of details, I would assume that it feels terribly unpredictable. I can feel that sometimes myself, to be perfectly honest.
And then you do this for a living.
Yeah, and then there is a weekend which resets balances, and perhaps on Monday you have better luck.
Yeah. And I don't not know if we mentioned the SACN View application.
No, yes, that's a good one.
That's a good one for just making simple streaming ACN tests. You can generate streaming ACN, you can receive streaming ACN, and so on. And I would also like to point out for everyone out there being manufacturers of fixtures or so, if you're implementing RDM, you should also have a look at the Open Lighting architecture. It's an open source project. They have built up a quite large and the test suite for RDM responders, so it can run a lot of automated tests on your responder code, your RDM responder, to make sure that it responds according to the RDM standard. And I guess it would be kind of neat to have that when it comes to the other protocol suites as well.
There is a new application out there. I don't remember the name. It was recently announced that does some testing is the wrong word, but it sort of tries to diagnose what's going on with a few different protocols, also including OSC, I believe.
Okay, yeah.
And MIDI. We'll include that in the links as well.
Yeah. Let me check here if we got any questions. No, not so far. So we've almost been speaking for an hour.
All right, yeah.
If there's any questions so far, post them. And otherwise, if you get questions in hindsight, you can post them as comment on the published video afterwards, and we get back to you that way. But yeah, Lars, thanks for coming.
Thanks for having me.
Yeah, and for your viewers, thanks for watching. Until next time.